So this is reviewing what we did yesterday. Hopefully you watched the video. Okay. Anyway. Okay. Might be a good idea to get the paper out. Didn't watch the video, did you? Nope. Anybody watch the video? Okay, good. All right. It involves me. Bounce the ball. You watch the video about a bounce the ball? That's funny. And we talked about how the ball bounces. And whether it bounces with the same group. We did a table of it. And we found a way to predict how tall it was after 3 bounces. Okay. The main idea of this chapter. Right, Mr. Water? Yes. Predicting the height after so many bounces because that value, all right, that value is consistent. I'm going to borrow your desk for a second. So like if I drop it here, catch it here, and then I drop it again, is the fraction, the proportional amount that it came back going to be consistent as it keeps bouncing? Yeah, it will, because it's not going to be pulled any differently with gravity. Gravity is consistent. So that amount is going to stay the same. That's what the rebound ratio is. Okay? Rebound ratio is the amount that it rebounds. What percent does it come back to? And using that, we can write an equation that models. All right, so back in here. Every class. All right, so get the rebound ratio. Rebound ratio is the rebound height over the drop height. So for our ball here, that's 2,750 over 3,000. And I'm going to use a calculator to get that decimal. So it's about approximately 0.917. Okay, so it rebounds about 9.917 from where it was originally. So if we think about the ball, it's going to come back up here. Now to get the second bounce, it's going to be 0.96 of this, where it's at right here. And then 0.991, I'm sorry, 0.91 of where it's there, 0.91 there, consistently. So when I'm repeating the same multiplication, so if it's originally 3,000, and I'm going to take it times that 0.917 to get the first bounce, right? Which is the, because that came from here, because if I take the 3,000 times this, I'm going to get that 2750. Because it keeps doing that same ratio as it bounces, we have a repeated multiplication. What's another name for repeated multiplication? What if I do 2 times 2 times 2 times 2? What would be a short, another way of writing that? An exponent. These are called exponentials because it's an exponent. Okay. So if I do this times 0.917 times 0.917 and just keep going, then it tells me what all my bounces are. So my equation looks like this. Where A is the starting height. Okay. B is my ratio, also called the multiplier. What are you multiplying every time? And X is the number of bounces. So what would our equation be? Y equals, what's A? 3,000. And I'm going to, and for the B, even though there's not a parenthesis, I'm going to put parentheses so I know that the numbers are separated. What would I put here? It's times what? 0.917 to the X power. And the reason we want to write the equation is because, look at the next problem. Do I want to have to multiply this times 11 times? No. The equation is going to make it easier. All I have to do is put 11 in for X. And then I use my calculator. Okay. And it would be 1,156.602. That would be the height after 11 bounces. Questions? Just to give you an idea, this problem came off of a test from 2 years ago. So you're going to be expected to be able to do this on a test. Please remember, ladies and gentlemen, on your day you're at home is not a day off. Understand that. Day at home is not a day off. You are still required to do some assignments, do an assignment, and do learning. Okay? It is not a day off. So understand that. So that's why I posted the video. The video yesterday was posted like right before the end of class. Okay? You're expected to watch it or zoom in and listen to it as we do it. That's your choice. Okay? You can, if you don't want to watch it, do it later, you can zoom in and just listen as we do it. And that way you can also get your questions answered right away. And you don't fall behind. That is the key thing. You don't want to fall behind. Questions? Okay. So this right here is an example, this rebound ratio is an example of something called a geometric sequence, and that's what we're going to look at today. We're going to look at more geometric sequences. All right. And let's talk about geometric sequences. First of all, you gotta have to know what a sequence is, right? A sequence is just a pattern of numbers. It's a number pattern. But it's a special kind of number pattern. A geometric sequence is one that does this. That's a geometric sequence. Now don't write this one down. I'm gonna erase it, but this one is not a geometric sequence. So this one is not one. This one is. How do you tell the difference between a geometric sequence and any other number pattern? Let's get a little more generic, right? A little more. What does double mean? Multiplying, all right? This one's multiplying, and this one is? What's this one doing? Adding to. A geometric sequence is where you're multiplying by that same number every single time. Okay, so a geometric sequence is a number pattern where you are multiplying by the same value. Okay, and that value is called the common ratio. All right. So geometric sequence. We're going to learn about the other one a little bit later on. Geometric sequence is a pattern where the same value called the common ratio is multiplied to find the next number. And we're going to get a little bit more formal on it, but for right now, that's the basics of it. Each of those numbers is called a term. Okay. So let's start with this one. Let's just talk about how a sequence is broken down. All right. So if I have this sequence here, Okay. This is a geometric sequence because it's doing what each time? It's multiplying by 3. What if you couldn't tell right away? So here's how we're going to do it. So each of these is a term. So this is term 1, term 2, and like this one is term 4. Each value in that sequence, they're all separated, they're not being added together. Each value is a term. A term is the individual number in that sequence. What would be term 5? So then you would do 27 times 3, okay? If you wanted term 10, you would keep going until you get 10, right? Okay. Is that very similar to what we just did in our warm-up, finding a value that's because we're multiplying by the same number? Yeah, it's the same idea. The first term has a notation of a sub 1. Remember how we talked about x1 and y1 in slope? It just means the first one. That's it. So in this case, this one would be 1. Tell me what a sub 3 is. It's 9. Question so far? Okay. Now the formula for writing it. So what if I didn't know my ratio? So the common ratio, this is easy, right? You can look at this one and say, oh, I know it's this, right? I know it's 3, right? You can see it's multiple. But what if you didn't know? You pick a term and divide it by the one in front of it. So an easy way to do it is take term 2 divided by term 1. What's term 2? Divided by term 1. So that would be 3 over 1, which is 3. What if I did term 4 divided by term 2? Or not, excuse me, not term 2, term 3. It's 27 over 9, which is still 3. So it doesn't matter as long as you get 2 terms that are side by side. The one there and the one in front of it. Because sometimes we're not going to give you the first 2. We're going to say we have this term and this one. We need to find it. Does that make sense? The general way it's written is a sub n, where n is a number, over a sub n minus 1. That is the general formula for it. Now you're probably thinking, well, wait a second, what if n is 7, what's this number? 6, it's 7 minus 1, okay? So now let's talk about the explicit formula. Explicit formula just means the equation. And then we're going to practice this, okay? This is otherwise known as the equation. And that is a sub, actually, I'm not going to use the equal sign there. I'm going to put colon. A sub n equals a sub 1 times, and it's an r, 3n minus 1. Well, think about this. Let's go up here. Let's write this equation here. So if I write this, what's my first term? What's the first term up here?
1.
1. What's my ratio? What am I multiplying by?
3.
3. If I didn't have If I just had it as in, if I just had it as in, and I wanted the first term, I would put a 1 there, right?
Yeah.
Okay. What's 3 to the first power? Times 1? Is that the first number there? No, it's not. So that's why we have to have that -1. We have to go backwards. Are you going to want a calculator for this? Yes. You're going to want to use a calculator. So if you have a calculator, get it out. I showed yesterday how to use your phone for it. I'll show again. I don't know where I left my phone. Oh, there it is. I lose things all the time. Okay. All right, so when you have a calculator, if you want to use exponents, you're going to turn it to its side. Come on. There we go. This button right here that has an XY is the one you want to use. Okay? So we're going to put n minus 1 here. Go back to that n minus 1. Now I want to find, let's log, give me a number. Let's not do above 10. So pick a number between 1 and 10. 8. I want to find the 8th term of this sequence. So n is equal to 8. Remember the term number is n. So that means 8, a sub 8 equals 1 minus 3 to the 8 minus 1. Why did that just jump? I don't know. That's not minus, it's 50 times. All right, what's 8 minus 1?
7.
Could you do that in your head? So you don't have to use your calculator on that part? Yeah, just take 1 less. Now put in your calculator. 1 times 3. You press the exponent button. It's right here. It says xy to the 7th power equals. And that gives you the term. Okay. Did everybody get that on their calculator? You need a calculator for this stuff, guys. Get one out. You don't want to do it, try and do it in your head. That will take way too long. You can use your phone or you can use a regular calculator. All right. So let's do some examples. So the first thing I want to do is I want to state the common ratio. Two, I want to write the equation. And then 3. You want to just use 8th term, this logo? Eight. So the equation is going to have the n. So this is basically 8th term is when n equals 8. Okay. Give you a chance to copy that down. And then we'll go practice. So let's start with that one.
Wait, who's happy?
It still has to be multiplication. You have to rewrite the division as a multiplication problem. Okay. So state the common, so part one, common ratio. Remember, you take one term divided by the one in front of it. So I'm going to ask Joy, pick a term. Okay, what number's in front of it? Nope. Here, then the number in front.
Oh.
2. Can I reduce that? 1/2? No, there's my ratio. Okay. Could she have done 2 and then 4?
No.
Yeah,
Oh, yeah.
you could pick any number, any term that you know, as long as you know the one in front of it. You got to know the one in front of it, okay? So I could have done 4/8 and then reduce it to 1/2. With these people. Now let's write the equation. A sub n equals the first number, which is, what's the first number in the sequence? 8. Parenthesis my r times to the n minus 1 power. Now what's step 3? Find the 8th term, so a sub 8. Well, that's going to be 8 times 1/2. What's my exponent?
7.
7. Okay, let's use a calculator. Okay. So you may want to put the 8 in. So 8 times. Now here's the thing, guys. You're going to want to use your parentheses or change this to a decimal if you're using your calculator on your phone. If you're using one of my calculators, you don't have to. There's a fraction key on those. These don't have a fraction key. So I'm going to use my parentheses. 1 divided by 2, close my parenthesis, and it changes it to a 2.5. That's what it is, right? Exponent 7. Okay. I don't know why that. There we go. That's what you got to do. Okay. You want to try some more?
Yeah.
Let's do another one. Okay, try it. I'm going to walk around and help you out. Okay. Vago, you want to do that side of the room and I'll do this side? If you're doing 1 and 2, it's 2 over 1.
Oh, okay.
It's 2 over 1.
Oh, which one?
Eighth term. Okay, same thing here. Remember, it's 2, if you're using the first 2 terms, it's 2 over 1. 2 over 1. Good. So this- that's the equation. Which two, no, if they were using the second and the first term. Oh. All right, yeah, they're using the first and the second. term. Okay. It depends on which one you pick. Okay. And then you have 1 over 2. Right. You start. Okay, so you're using the second term over the first term? Yeah, you erase it. That's what they were doing. They were using, I was talking about their term number. Oh, yes. You pick a term, that's term 1, right? So what's the one after it? This is term 2. So if you want to use those 2 terms to find your R, it's term 2 over term 1. Okay, so it's the second number over the first number. And then reduce it. Okay, so reduce that, let's do 6 divided by 2. Mhm. That's your R values. Yep, okay, now write the equation. You see, it's huge number. Yeah, what's your first number? Okay, yeah, you don't do this. You don't multiply that.
So I do the rest of this right?
That's why you want to type it in the calculator exactly the way it is. No, your first term, no. Well, look here, what do you write here? What do you write here?
Here, I'd offer.
Give the other numbers. Yeah. So far, like, you see the other way. It's same thing, yeah, it is, but, because there is no such thing as a term 0. That's why when I first started, I was like, please.
Wait.
Yeah, it's messing with me. This is what I know. This is the way I know it. This is what, the problem is, like, if I go to help, like, with my nieces and nephews and stuff, I have to go backwards to back to this way. Okay, now hold up here.
So now.
This is your first term. This is your first term up here. This is the first number. Oh, 2, so it should be 2. And 2. Okay. Okay, so now, here's what you're going to start the change that to a 2. You're going to accidentally type in the wrong thing. All right, so you're going to press 2. Parentheses. 3 negative. You have to do the 3 first, and then do your parentheses. Negative. Or your parentheses. X8 is right there. See how it's 8? No. See how it's 8? See how it has the X and the Y? Like that, and then your exponent. There you go.
Slow bit.
Yeah. No, you're not multiplying those. You gotta put this in the calculator exactly the way this is. So that the calculator does the exponent first, and then. Order of operations. Okay. So, 2, parentheses, 3 negative, parentheses, exponent. 7. There you go. Okay. Because if you want to test it, seriously, all you have to do is this. Take negative 54, negative. This is where 54 negative. It's putting it in a calculator. Yeah, it is rough. 54 negative, right? Times what you multiply. Negative 3, right? 2 negative equals the next number. We have, right? Times 3 negative. So that would be, so that's 1, 2, 3, 4, 5, 6, right? Times 3 negative. 7, so we need 8, right? Times 3 negative. Whoa, I was just confused. And huh? She did. Okay, I will. This pencil. See, the thing is, parents put like nicknames in Aries for students. And we figure that's what you want to be called. And I'll say that, and they're like, "Please don't call me that." That's why for my daughter, her real name is Kathleen. She does not like Kathleen at all. And so if I want to irritate her, I call her Kathleen. I think it's a great name because it's my grandmother. She's named after my grandma. All right, so here we go. So the first thing we got to do is find our R. Now, many of you use the -6 and 2. That's okay. I'm going to use the -54 and 18. Can I do that? Yes. You just want to be a contrary, don't you? You just want to argue with me. Okay, I can take any two terms as long as they're side by side. And that's going to give me a -3. My equation, a sub n equals the first number in my sequence times my r to the n minus 1 power. So now I want the eighth term. Eight minus 1. Pull on my calculator. 2 parentheses -3 to the 7. Likely mistakes are from typing in the calculator.
I want to see how you type in that.
Here. Okay, you watch what I do?
Yeah.
First clear it up. 2 parentheses 3 negative
Yeah.
parentheses. Then press the exponent key. 7. No, what's going on?
No, I think you're.
I didn't close I don't think I closed the parentheses.
I did that. That's okay.
Yeah, I got it. All right. Hold on. Let me double check this. I think I know what the issue is. This is why I don't like these things. Did you, You got -4?
Yeah, just did 2 times -3 to the rest of it.
You don't necessarily have to put the parentheses. You have to use them to supply it.
2 times
2 times
2 times 3 negative exponent 7.
Don't use parentheses.
See, that shouldn't matter. That's the thing, the parentheses shouldn't matter, so just don't, yeah,
Don't use parentheses.
don't use the parentheses. It
Okay.
honestly shouldn't matter, because parentheses.
Wait, so which one's right? Now,
This one is right. All right. Questions? Want to try a different one?
Yeah.
Let's do another one. One that's not so easy to see, Ms. Wago? Okay. That one was easy to see. Okay, try this one. I'll be right back, Miss Largo. I'm going to fill my water. You got it? Skylar, you okay? Oh, here, how's P6 to 3? So 40 over 2 is 1. Use your calculator. You don't have to reduce it, just use the calculator to divide it. Yeah, don't. So to get my R, I can use -6 divided by -4, and that gives me 1.5. Doesn't have to be a fraction, guys. A sub n is going to equal my first number, which is -4, times my ratio to the n minus 1. Now I need the eighth one. -4 times 1 minus 5. 8 minus 1. So that's -4 times 1.5. 8 minus 1 is 7. negative 68.31 or 34375.
Okay, how do you do on the?
Did you use parentheses? Are you doing your phone? Remember, we decided no parentheses on the phone. Four negative times 1.5 to the 7.
68, okay.
Okay? All right, ladies and gentlemen, I am done. Your assignment